Hi, everyone. Okay, so in this lesson, we're essentially going to be dealing with word problems and solving them. And I'm going to focus mostly on the setup because we've already learned how to solve. This coin problem, we could have two approaches, but let's go ahead and just read through it and then I'll talk a little more. So Angel has $5.45 in quarters and dimes. We know quarters are worth 25 cents. We know dimes are worth 10 cents. So that's not unknown, the value of a coin. He has 5 fewer dimes than quarters. So what is unknown is the number of quarters and the number of dimes. Again, you could even see that in the question, how many of each coin? So when you establish your variables, reminder that you establish them correctly. They should be unknown values or unknown numbers. If you forgot that, you should write this down. Unknown values. So we can establish, I'm going to use Q and D. My Q is going to be my number of quarters. You'll never see me start a word problem any other way. I always start with establishing the variables. D is going to be the number of dimes. So, what do I know? Well, I do know that if I take the value of a quarter, let's say I have 2 quarters. How much money is that? 50 cents. How'd you get that? Well, if you do 2 times 25, you get 50. So if you, again, what I just did there was I used a strategy where I kind of said, okay, I'm not sure what this problem is saying, but what I do know is if I take the value of a quarter and multiply it by the number of quarters, I get my total value for the quarters. And if I do that with dimes and add that all together, I get my total value. So if I take 0.25 Q and add that to 0.10 D, I get 545. So again, what is this equation saying? This equation is saying that if you take your number of quarters right here and multiply that by 0.25, you'll have the value of your quarters. And if you do the same thing with the number of dimes times the value of dimes, you'll have your total value of the dimes. Add that together, you get $5.45. The other thing that we do know is that we have 5 fewer dimes than quarters. So I have to ask myself, is this going to be Q plus 5 is equal to D? So am I going to add 5 to my number of quarters to get my number of dimes? That doesn't make sense, right? Because we have less dimes. We have to add 5 to our number of dimes to get our number of quarters. Or you could think of it as if you take 5 away from your number of quarters, you get your number of dimes. So when I say two approaches, that's really the two approaches I'm talking about. You can think of this as subtraction or you can think of it as addition. I'm going to think of it as addition, but you're fine to do it as subtraction. So what does that mean? Well, that means that I can replace this Q down here because they're equal, right? Q is equal to D plus 5. I can replace that Q with D plus 5. And this is what I was talking about in the beginning. I'm not going to actually solve this equation. We've learned how to solve it. Instead, I'm just going to jump right into what the answer would be. So if we solve this correctly, and if you're having trouble, you should try solving it yourself. See if you can do it. And, you could honestly use a calculator if you wanted to. I know decimals. We'll talk later in the future about how to get rid of decimals, how to get rid of fractions. It's called clearing fractions and decimals. But we're not going to talk about that today. What you get is you get D is going to be equal to 12. So that means you have 12 dimes. And if you have 5 more quarters, you'll have 17 quarters. Okay. Next one, age problem. These can be these can get confusing. Sometimes you have to read them multiple times. 16 years from now, Tia's age will be twice her age 12 years ago. What is Tia's current age in years? So let's start with what's unknown, which is Tia's current age. I'm just going to mark that with a T. I could use a lowercase t. Tia's current age. Apologize for my handwriting. I don't have my pen left it at home. So, all right. Now, what we know is that 16 years from now, Tia's age will be. That is actually an equals part right there. So 16 years from now, so if we add 16 to Tia's current age, that would be twice her age 12 years ago. So 12 years ago means take 12 off her current age and multiply that by 2. So does that look like this? Not quite. Because what are we multiplying by 2? We're multiplying her age from 12 years ago by 2. So we need parentheses around this because we need to subtract 12 first off her current age. It could help you, honestly. It might help to use a number for her current age. Just make it up and go with it for now. Like, let's say her current age is 10, right? That means that we would want to double. Well, maybe 12 is a bad, 10 is a bad example. Let's use 15. Let's say she's 15 years old. Double her age 12 years ago. You would subtract 12 first, then multiply that by 2. Okay. So that can help you out if you want to use a real number. So what we end up here is, if we solve this correctly, is t is equal to 40. That is her current age. Okay, last example here. Selling tickets to a school play. Adult tickets cost $10 each, and student tickets are $6 each. He sells 15 fewer student tickets than adult tickets. If John's ticket sales are 326 total, how many student tickets does he sell? So this is actually very similar to the coin problem that we saw, where we have a value for each type of object or number, and then we have a total amount. So we're going to set it up the same way. What we have here, and we're not going to have to deal with decimals, which is nice, we have two unknowns. We have the number of student tickets and the number of adult tickets. So we could use A and S for that. But again, it's not S's student. It's S's number of what? Student tickets sold. Not the value of a student ticket. We know that. Student tickets are $6 each. So my S is going to be number of student tickets sold, or number of students in general, right? Same thing. Number of adults, or number of adult tickets sold. Okay, so adult tickets are $10 each and student tickets are $6 each, similar to the coin problem. Take the value of an adult ticket, multiply it by the number of adult tickets, you get your total value of the adults. So 10A plus 6S is going to be my 326. And what else do we know? We know that we sold less student tickets, right? He sells 15 fewer student tickets. So I need to add 15 to the number of student tickets to get my number of adult tickets. You could also think of it as, well, you sold, if you take 15 off the number of adult tickets, it's the same thing as your number of student tickets. So you could think of it that way. I always generally think in terms of addition. So that means that I can actually take this, and since that's what A is equal to, I can replace the A down there with that. Just remember, when you substitute, use parentheses. So it goes around that variable, and what it's equal to goes inside that parentheses. And if I solve this equation correctly, now I only have one variable, S. If I solve this correctly, I end up with my number of student tickets being 11, which means that if I think about it, I sold 15 more adults. That means my number of adults is 26. And if you wanted to check your answer, you could actually check it because you know the value you should have. That would mean you sold $260 worth of adults. You sold $66 worth of student tickets. Add that together, what's it come out as? 326. Hey, that matches. You know you did it correctly. So you can substitute it back in just to check. And there you go.